Hi everyone! For this video, we're going to talk about ellipse. So let's start with the parts. So I have here a horizontal ellipse and a vertical ellipse. So the first part is the center. Just like circle, ellipse also has a center. So for this drawing, the center is at the origin, 0, 0. Then we also have the major axis and the minor axis. So the major axis is the longest diameter of the ellipse. So in this case, it's from here up to this point. Okay, and the length of the major axis from the center to the other end of the diameter will represent that as A. So the overall length will be equal to 2A. So for the vertical ellipse, so this is A from the center, and that's another A. So that's 2A. Now for the length of the minor axis, so that's the shorter diameter of the ellipse. So let's represent that as B. So for vertical ellipse, this is our B. There. So therefore, the length of the minor axis will be equal to 2B. So A is the distance from the center to the vertex. So distance from the center to the vertex. So this is vertex 1, this is vertex 2. So for vertical ellipse, this is the vertex 1, this is the vertex 2. So the coordinate of the vertices would be plus or minus A and 0. And for the coordinates of the vertices of a vertical ellipse would be equal to 0 plus or minus A. We also have the co-vertices, or that's the minor axis vertices. So this one, let's call it VC. So therefore, B is the distance from the center to the co-vertices. So the coordinates of the minor vertices would be a 0 plus minus B. And for the vertical ellipse, the coordinates of the minor vertices would be plus or minus B and 0. An ellipse also has two foci, and the foci is along the major axis. So, and that is C units from the center. So let's say this is F, so that is C units. Okay, so for vertical ellipse, the foci is along the y-axis or the major axis. So in this case, this is F, and that is C units from the center. So the coordinates of the foci for the horizontal ellipse would be plus or minus C, 0. And for the vertical ellipse, the coordinates of the foci would be at 0, plus or minus C. So the standard equation of an ellipse with center at the origin. So for this horizontal ellipse, we'll have x squared is equal to a squared plus y squared over b squared equals 1. And for the vertical ellipse, that would be x squared over b squared plus y squared over a squared equals 1. So as you can see here, the a squared is the one with the major axis. In ellipse, a is always greater than b. So a is the length of the minor axis from the center to the other vertex. So if the larger number is under x squared, it means your ellipse is horizontal. If the larger number is under y squared, then your ellipse is vertical. And also, if you're given the a and b, you can find the value of c with the formula c squared is equal to a squared minus b squared. Now, what will happen if the center of the ellipse is shifted to HK? So the center now is not at the origin, but at HK. So what will happen to these coordinates and equation? So this equation would become x minus h squared over a squared plus y minus k squared over b squared equals 1. And for the foci, it will become h plus or minus c and then k. For the major vertices, the coordinates would be h plus or minus a and k. And for the minor vertices, it would be h, k plus or minus b. And for the vertical ellipse, this equation would become x minus h squared over b squared plus y minus k squared over a squared equals 1. And for the coordinates of the foci would be h and k plus or minus c. For the major vertices, the coordinates would be at h and then k plus or minus a. And the minor vertices coordinates would be at h plus or minus b and k. So again, pause this video to take a screenshot or copy the notes, and the next video we're going to solve some problems in finding the coordinates of the foci, vertices, and center of an ellipse. Thank you.